Why modules? The code written in interpreter gets lost as soon as the interpreter is closed, right? So whatever I have written here, as soon as I close this, these are all gone, right? So how do I save it? How do I save the functions that I write? Let's assume this is a very handy function, right? Let's assume this is a very handy function. How do I keep it? Okay. Oh, sorry. So the way to do it is, hence we have scripts which can retain the code. So what we do is, we save this as a Python scripts, command.py. So every time you see this, the way I pull out the code, right? I say open, and then I would have saved this as, you see here, scikit, import pandas. I'm not pulling something kmeans.py. Okay, this is some code, open, module 8, Python module, scikit pandas, machine learning, building a classifier. Okay, you see here, all I have done is, there are many codes here, right? Scikit.py, kmeans.py, building classifier.py, sumtest2.py. So all I do is, I save this code, okay, so that I can not only use in this place, I can also use this wherever I want to. All I have to do is, I have to import it. Now how do I import it? I'm just going to show it to you. So however the functions, okay, this is the same story. Importing a module. Now let me show you. Accessing functions and other items inside a module. You know, I have been doing this. You just say import this function, and then as soon as you give a dot, that's what we have been seeing, right? See here, you say import from NumPy, import star. I say import calendar as CD, and if I do CD dot, it'll give me everything. Okay, that's what it's trying to say here. You can do from my module import a particular function. See here, if you do a CD dot, there are so many, right? You can say import from calendar import only. You can only import one function as well. Let's say error, right? You either import one function or you import all the functions, okay? Or instead of doing this, you can just say import calendar, and it will import everything. So there are various ways to do it. That's all. No big deal here. It's the same thing. Sys module. The sys module is used for controlling and interacting with Python interpreter. It includes information about operating system and version of Python that you are using. If you remember, couple of maybe an hour and a half back, I used sys.exit. So basically, it is relating to system. It says get out of this program or get out of this function, right? To use sys module, import sys. To work with feature in sys module, type sys, a dot and a name. So basically, it's the same thing. Import sys and then say sys dot. You have all this. See exit. See, if I say sys.exit, this is what I use sometimes back. So again, it's about package usage. So do not worry about package usage. Okay, worry about understanding the basic Python, and the package will automatically come to you. Even if you do not understand the package, all you have to go to is docs.python.org and read about this package, the functions that each of the function in those packages that it does, right? What each of those functions in the package does. So all you have to do is go there, read about it, and you'll be good with it. But your first task would be to understand the basic functionality or basic feature of Python, and you'll be able to easily adapt to packages. See, note, to find all functions present in sys module, type help sys on Python console. Okay, you can either do that, or if you have see, the best way to do for me is, I love this, okay, in PyCharm, and everything comes. You can also do a help of sys. You see here, along with examples, okay? Or if you are using idle, you just say help, okay, just say help, and you say sys, and then you have everything. Easy, right? No big deal. Okay, so okay, these are some of the common data functions. Sys.exist, you already know. Sys.argument will give you the list of all the arguments that you have passed. So again, these are some common functions. Okay, you know what is exist. We have also seen sys.argument. It stores any command line argument in you passed when you started the Python, right? Also include the name of the program that you are running. You say length of sys.argv will give you all the length of your number of arguments that you have passed. Argv of 0 will give you the first argument, which is the name of the program. Standard in used by input and raw input functions. Okay. Standard out again used by print statement. Your standard error stores error message. So these are common functions in sys module. So again, there are OS and subprocess modules. We'll walk you through this briefly. OS and subprocess modules includes code that lets Python work with operating system. You know, right? OS is operating system package, and now this acts as an interface between your Python and operating system. They even run operating system commands. You can run your operating system commands using the OS and subprocess package. The OS module is best for the following tasks. I'll show you. I'll give you an example as to where OS module is used. So working with paths and permissions, that's where OS module is used. Working with files, that's where OS module is used. The subprocess module lets you safely interact with operating system to run commands and get information out of them. So subprocess is something which acts as an interface between your program and your OS, right? And then OS module takes care of interacting with OS. Now let me show this. Let me say import OS. Okay, OS is import. Now if I say print or just say os.get common current working directory, it gives you as to where I am, right? So this is the path where I need to place all my libraries XSR. See Python 27 libraries folder will have all your packages. Okay, let's say I want to execute some file, okay, which is in module 3. Let's say, for example, Python, we are in module 3 and some code, and then I have, let's see this. Okay, I have to execute this. Let me try to execute this. So all I have to do is exec execute file and code, the name of the file. See this? So I am able to, after I have imported my, let's import OS, and then I'm saying get current working directory. Now let's say my code is somewhere else. It's not on the path in C27. Now see, this is somewhere, okay? This is somewhere else. It's not on the path where I have installed my Python. So all I have to do is I have to say exec file, or I can say system dot your path, right? In my path, let me append it. Now you can see all these functions which are already available, right? All you have to do is, okay, import OS, and I have to do an import sys as well, because I closed my session, right? If I do not do this, it will not take sys. So sys.path.append, and I can say in that OS path, os.path dot my absolute path, and let me give you my absolute path. Oops, this is not my absolute path. This is my absolute path. So when I do this, see, all I did was I used a package called os_path.absolute_path in order to identify the path, and then I'm appending that to my system path. Okay. Now if I, after this, if I say import, okay, no module name py. Okay, in the end, it's a code error. Okay, def example.py. I should have properly handled it. I have not handled, so that's fine. But regardless of that, as soon as I say import, it is able to import my file. It's executing here as well, which is something which it should not do. But my code, this particular module was not meant to be imported. I mean, it's just a dummy module that I have created, right? See here, all it does is it just prints it'll call this and it'll print here. Okay, so if you go here, all it does is it's appending the path to the system, and hence I'm able to import it. So these are few of the stuff that your sys module and OS module are able to achieve. Okay, apart from that, you have change directory as well. You can change your OS directory from one particular path to another particular path. Yeah. Okay, Mohammed, you are good. See, it's here, os.change directory. Yes, we can do that as well. We can make directory as well. We can make directories as well, right? And then you can pass your what's that? This is the mode, right? 0777, which is user group owners or others. Sorry, UGO, right? Same command like change directory. Yes, Santo. It's the same command like Unix. You can remove as well. You can remove directories as well, so on and so forth, right? See, if you have to remove multiple directories within a directory, you can just say remove directories. And this is the same. You can join paths as well. OS path join. You can OS path absolute path. You saw that takes the relative path name and returns the corresponding absolute path name. Yeah. In case of Unix, see, all these are given as a Unix. Okay, this screenshot is for Unix, right? But then if you have a Mac system, you can do exactly as what is done here. In case of your Windows system, instead of $home, you $/home, you can use C:\/. So again, some more other functions related to OS. And subprocess module, yes, it will work on any OS. It will work on Linux, it will work on Windows, it will work on Mac. Okay. So subprocess module lets you interact with the operating system to create new process, pass information into and out of them, and get the return codes. Subprocess can be used using call functions. So you can do something like this, subprocess.call, right? Here you see. And it is process.call, and then you say ls. Okay, it says, okay, the system cannot find the file specified. My subprocess package itself is not available in my C Python 27 libraries. Where's subprocess? Okay, it should have found it here, but it's not able to find it. Oh, okay. What I would do is, it's simple for me. Yeah, it's double L. Okay, the system cannot find this file specified in execute. Okay, looks like, did I change the file? I don't know. So I'll have to go and look into this as to what the problem is. I don't know if I must have played around with it or manipulated it. I don't know. It says C Python subprocess.py in execute child. So there is some problem here. No, I opened a new one. I opened a new idle. Yes, Mohammed, I tried that. It's a new one. I closed the previous one and opened a new one. So it looks like I would have played around with it, or some of my program would have modified it. So I need to download new packets. I keep doing something or the other. So basically that screwed up my whole thing. So anyway, so you know it, right? Basically, if you do this, I think if you do this in your system, it will work. So, and moving forward, there is math module as well. In math module, there are math functions are broadly classified into number, power and logarithmic, trigonometric, angular, hyperbolic, spatial, constants, etc. So don't worry about math module much. Okay, I would say that please, and I repeat, don't worry much about math module, because we have far, far bigger packages and far powerful packages than the math module here. Okay, that will come with numerical Python, scientific Python, pandas, and so on and so forth. So do not worry at all about math module right now. If you want to see it, it's okay, but don't go very deep into it, because we have similar packages which are much better and powerful than math module, which I'm going to talk about later. I mean, in my, of course, in my 4th or 5th class, not 4th, 5th class, I think. So basically, some of the math number theoretic function, if you do a ceil, you get the next available number, right? If you say ceil of 10.01, it will take, it will give you 11. Math of copy sign, if you do it, just copy the sign from here. Math.f absolute, then it will give you absolute value, so on and so forth. So basically, there is no logic here, right? There is nothing to explain either. It's a function. You know, if you know what it is, you'll be able to use it. So let's say, for example, if you say this will return you e to the power of x, right? Maths of exponential to the power 2 will give you some value, e to the power of 2, right? And so on and so forth. Log, cos, sine, tan, cos, right? This is cos of x, maths of a cos, and this is cos. Okay, this is arc cosine of x. Now these are all mathematics. So if you are interested, you can look into it. But I would still suggest that you hold on for some time when I will explain about numerical Python and scientific Python, and you can use those. Degrees, radians, pi. You know what's pi, right? 3.14. See, pi. Math to the power e. This is the value of e, constant, 2.7182. Random range, it generates, if you want to generate a random number from 100 values, it just gives you random range, and it's again start, step, stop, right? Start, stop, step. So it'll give you 20. This can give you any values from 0 to 100. It will give you any values from 0 to 100, but which will be a multiple of 10. A random integer. So datetime module, there's again datetime module as well. So on and so see, we are just discussing about one calendar, right? So it's similar to that. We have a datetime module as well, wherein we have datetime function. So an object that stores dates and time information like this, and they are all in hexadecimal numbers. Calculating time difference. When you perform arithmetic on datetime objects, you will get the result in time delta objects. It attributes are days, seconds, and microseconds. So for example, if you take a particular date time, which is today, okay, let me do this for you. Just give me a second, guys. Okay, now I cannot copy. The bad part about this is I cannot just copy. I'll have to type it. Anyways, date time now equal to date time dot now. Okay, this will give me now other time. Okay, some other time equal to date time dot time. Okay. And now I'll take exactly 1969, 720. 1969 and then 7 and 20 and then hour, minute and second. Okay, 20 to 56, hour and minute. So that's fine. And then if I say print of now minus other, see here. So since then, so let's say if it is 2014, how many days have passed since then? It is 103 days, 7, right? 8, 9, 10, 11. This is today is 11. So 30, 60, 90. It's more than. So it gives you in the days difference plus hour, minute, and second.